Welcome back to the 8th video about my electronic steering wheel / Rudder Jog IP68 project. In the previous video, we milled our little POM block, which will be the body of the whole thing, to size. Card here, link in the description. In this video, we will put a whole lot of holes into it. Enjoy! Hi, this is Robert from the future. If you think drilling 10 holes will be boring, you're right in 9 of 10 cases. The 60 millimeter hole will be a total drama. I swear to you, there will be self-flagellation, but there will be also some math, trigonometry to be exact. Yeah, I made mistakes and I partly discovered, but I didn't get the job completely done. So yeah, drama. 10 to be exact. So we have 4 3.3 millimeter holes on the back, which will be later threaded M4. And we did all the markings for that also in the previous video. And we have an additional 8 millimeter hole here, which will take up a stop bolt, which we'll have to insert here. The front, there we have 4 5 millimeter holes. Also, the markings are already here, which will be later on threaded M6. And we have our huge 16 millimeter hole through the whole body, which will take up the shaft. I think I also mentioned that in the previous video, but the reason I'm doing all these holes now is that it's much easier to put that thing into a vise and align the drill while it's all, flat and square. While when we do with the mill all the round features on that, then aligning stuff and clamping it into a vise is a little bit more complicated. So let's do all the holes now. And to give me a chance to warm up, we will start with the smallest hole of 3 millimeters, then go to the 8 millimeter here because we already have that side up in the vise, and then we continue with the 5 millimeters, and finally we will do the big 16 millimeter hole in a whole lot of steps, because I also mentioned that before. My little mill is not really capable of doing 60 millimeters, so the last few steps will be 0.5 millimeter steps in diameter. As always, I have the piece sitting on 2 parallels in the vise, so I really know it's sitting on the bottom. I aligned my piece in the X direction using my brand spanking new pointed metal shaft, which is currently sitting upward there in a normal chuck for the drills we will be using. Card here, link in the description. And we're practically down in the tolerance, to the run out of my drill chuck plus the run out of my spindle, which is good. And on the y-axis we're looking good too, though that shadow, and I can't get rid of that shadow, it makes the reading really hard, but we're left and right on the extremes of the scribed line. That should be okay. And now we shall drill with 3.3 millimeters. Now we want to go 21.5 millimeters down, so I keeping the depth scale here. Look at it. It's not really critical if it's just 21 or 22, but about-ish. So I'm just touching here, and now I will jot down my depth, which is currently 12.5 plus 21, so we go down here to 34-ish. And we're there. I will repeat that now 3 times and then I'll come back to you. To my great shame, I have to admit that the first time around I forgot the center drill in between, so here's that step. Now for the 8mm hole, and I can just fit my drill in here. Yeah, there's not much space here at the edge, and my head is at the very top of the column. That's a bad omen for things to come, but for now it's okay. First we do, overexposure, I know, the optical alignment again. First on the x-axis, and seems about right. And the y-axis. Seems to be right too. Next we center drill, and I hope I can reach down far enough. No, not quite. Let me fiddle a little bit. Okay, we're using my latest and greatest HSS drill, and hopefully that will be okay. Finally, 8mm. And I want to drill a hole that is measured to the tip of the drill exactly 46.5 millimeters deep. Oh, I'm out of frame here at that depth. And like for the smaller holes, this should be right on spot. So I marked the depth here with a little bit of paper I wrapped around the drill, and I will also keep a close look at the scale. Looks like I overshot by a whole millimeter. That's not good, but it's not bad either. It's, I can work with that. I turned the block around. 5 more holes on the backside, and let's start with the 5mm holes for the M6 threads. So the head came significantly down again, so I can still insert here my 5mm drill, no problem. Now let's align the spindle on the first hole. X-axis is looking fine. Y-axis is looking fine too, is it? Yeah, it's okay. Here comes the center drill. And here's my next problem. I need to go 57 millimeters down, and I probably will be touching my chuck here at 56 millimeters, but that's okay. That's okay. As I said before, the depth of the holes is not that critical usually, but for that 8mm hole, which I missed by a millimeter, that hurts a little, but I can work around that. And I almost made a mistake. 57 was, it's out of frame on the scale. The depth of the hole is actually only 55 and 55. Yeah, I have that here on my caliper. That was, yeah, long before. Well, 1.5 millimeter before, 2 millimeters before I hit my chuck. And I will repeat that 4 times and then I come back to you. All 4 5 millimeter holes are done. And now, I already talked about a bad omen. We run into a little problem. Yeah, my head is at the very top of the column, and if I just hold here my 60 millimeter drill, we see there's not enough space here with all the height of my stack, the compound table, and the vise. So I will have to come up with a different solution. And the solution is, yeah, we're still at the uppermost position for our head here, to place the vise directly onto the base and do the whole thing without the compound table, which will be quite a chore. Now those lines I scribed into my column and into my head come in handy. Card here, link in the description. You'll see during the following operations I think about 8 different drills until we are up to 60 millimeters. We'll have to change the height of the head on the column each time. And without these markings, I never can be sure if my head rotated a little bit to the left or the right. And so we lose our 0 here on the piece and the hole goes anywhere but the center. The first step, lining here my crosshair on the piece on my little shaft, is also challenging because we no longer have a compound table. And yeah, I will have that vise at a very odd angle because I cannot get screws in here into the slots when I have it here straight, and this way is also not possible. And I fiddled around a little bit, and this way at that angle we're almost here under the center, and I can get in at least three screws, bolts, sorry. And so I will align now the piece or the center of the piece under my spindle by just, slightly hammering on the vise while it's only finger tight, torqued down on the base. Yeah, I'll come back to you when I'm done. The spindle is aligned over my scribed marks here, and yeah, that axis is absolutely okay. That axis is also looking good. And I really achieved that by just, tapping the vise while the bolts are only a little bit torqued into place on one axis, turning that thing 90 degrees, doing the same from the other side, returning and correcting and turning and correcting and turning and correcting and turning and correcting. And anyway, we're fine now. And remember, each time I have to change the height of my head on the column, I have to realign my head here with a lot of tapping counterclockwise and clockwise until the lines match up. But I won't film that in between, okay? Let's start with a center drill. Next up is 8 millimeters, well within the capabilities of that small mill. But I need a full 70 millimeters, and that's also in depth. That's also the maximum the Z-axis can do. So I put in here, I think that's 0.1, 0.2 millimeter aluminum sheet. And then I lower the head, and now I will align the head. 8 millimeter. Ten millimeters. 11 millimeters. We are now beyond the official capabilities, and there should be a little bit of struggle, but yeah, from experience, it should be doable. Eleven millimeters went really easy. Now we're at 12 millimeters. I know 12 millimeters is possible with yeah, the machine straining a little bit, because I already did a 12 millimeter hole here through POM for that project, my electronic throttle control levers. Card here, link in the description to that episode where I drilled that, hopefully. And back then I didn't make the intermediate step between 10 and 12 millimeters with 11 millimeters, so I don't expect any problems. Yeah, it stalled out a few times, the spindle that is, but that's okay. I mean, this is a very small spindle motor, a lot of torque here, so it's allowed to stall out once in a while. 13 millimeters, where no Proxon BFW 40/E spindle has gone before, at least not mine. That went really smooth. I stalled out only once. I mean, it's a brand new drill, probably very sharp, but still, I liked it. 40 millimeters. have the feeling now the larger the drill gets, the easier it gets, which is kind of a conundrum. Houston, we got a problem. On the, let's say that's the y-axis, the hole is pretty much centered. But let's call that the z-axis. We are visibly off center. Well, let's measure how far off the center I actually are. And we will call this the x-axis, and that's left, that's right. So this is the y-axis, that's the front, and that's the back. And as I do the measurements, it will get a little bit confusing. But anyway, here it goes. X-axis left, and I try to align that here to the best of my abilities, and we are at 27.23. Is that correct? 27.24. 27.24. Let's say 27.24. I turned the whole thing around 180 degrees, and on that side of the x-axis we come to 28.7172. Yeah, 28.72. Now y-axis front 27.7980. 27.80. The other side of the y-axis, and we are at 28.28. Not quite. 28.25. Let's say 28.25. So on the x-axis we had on the left side 27.24 and on the right side 28.72. That is a delta of 1.48 millimeters. And if you divide that by 2, that means our hole is offset on the x-axis by 0.74 millimeters. And by the way, here's the column just, for some orientation. So you see this is all a little bit at an angle. So y-axis 28.25 and 72.8 makes a delta of 0.45, and our hole is offset 0.225 millimeters. Not good, not terrible, but 0.74 millimeters, that's not 3 Röntgen, that's 15,000. How is that possible if my marks here, my scribed lines on the column and the head were all the time perfectly aligned? Because I'm stupid. I knew that any error here on my scribed line and the alignment with the head would be amplified out here by that large lever that the head is on my machine approximately 16 centimeters. But I said back then, it will be all right. Okay, I'm better now, the pills worked. So let's do the math I should have done in the first place to find out how sensitive that thing is to errors. So we have here a quarter circle, and yes, we do some trigonometry. And this is the length of our, let's call it arm. So how far out from the center of our column is the center of our spindle. That was 160 millimeters. And this should be normally at an angle of 0. But if we introduce here an error angle of alpha, then our hole wanders off the sine of alpha times the length of the column. And yeah, let's call that the X direction. That's not how mathematicians do that, but that's how my table is set up. Sorry. And this little arrow here we saw on the y-axis, that's actually, yeah, the green from here to here. That's the cosine of alpha. So what's left here, that little itty bit that was an offset of 0.225 millimeters, that's 1 minus the cosine of alpha times L. And now we can jiggle around some formulas. So if we take the arccosine from our arrow here, 0.74, divided by our length here, 160, we get an arrow alpha of 0.265 degrees. I also tried the math for our very little arrow here on the y-axis, but yeah, it's off. This is simply within the measurement errors I have. So let's continue with, we're assuming here that my head was misaligned by 0.265 degrees. My column has a diameter of 45 millimeters. You multiply that by pi and you get the circumference of the column with which is 141.372 millimeters. We divide that by 360 degrees and multiply that by that little offset. Yeah, we have 0.265 degrees. And that arrow on the circumference on the column, yeah, where my scribed lines are, is only 0.104 millimeters. So about-ish a tenth of a millimeter. If I'm a tenth of a millimeter off with my alignment, I get these huge errors. So just that we have all the same understanding about what we are talking about here. This is obviously extremely magnified, my scribed lines here, which I use to align. And I set my caliper here to 0.1 millimeters. You see that little thing here? Yeah. You see the problem. So my scribed lines are not completely useless. You can always use them for a rough initial positioning of the head. But obviously, yeah, for before actually doing some drilling, I have to do a little bit more. So for the remaining 4 drills, and we will now continue in 0.5 millimeter steps, so that's 14.5 millimeters, which is in here now. I will roughly align the head using the scribed line, and then using some plate here, that's an old PCB that went wrong. I will just so, because the drill is obviously not in the hole yet, I can put that here and then use my caliper to align that thing on both sides. And yeah, aligning means a little bit out of camera, knocking the column slightly left and right until I'm really centered. Wish me luck. I won't film the process because it will probably take 5 minutes or so, and I'm still a little bit rattled from my 15,000 Röntgen experience here. Okay, the whole process of aligning the drill almost took a quarter of an hour. I came up with 2 little enhancements to accelerate things. First, I clipped here my PCB to the drill, so I have 2 hands free to do the measurements. And second, after the initial measurement, I just calculated the average, and then I fixed, that's not the actual average, and then I fixed my caliper on that average and used it to shove the drill into the center position. Okay, that didn't work at the end. At the end, I had really to measure left and measure right, and then to hammer the head into position slightly. But anyway, we can now go ahead with 14.5 millimeters, quite offset to our initial hole. Just to show you how offset we are here. Yeah, it's quite a bit, and I'm a little bit concerned. I mean, the drill is extremely 14.5 millimeters. It won't flex. If something is flexing when I'm going down, and I will go very, very slowly this time, it's probably the mill. Yeah. 14.5 millimeters in extreme close up. So we can see that's the edge that probably won't touch or touch only very little the drill. Wish me luck. That was only 35 millimeters, not 70. And from that perspective, you might be able to see how the drill is deflecting a little bit when I go down. And now something overheated, and I have to wait until it's cooled down. Just a sec. Things cooled down so we can continue. And overheated again. Yeah, that's a fuse in the... Where is it? Oh, sorry. There's it. Fuse in the power supply if the transformer gets too hot. Sorry about that. Short break again. Last 4 millimeters. I hope I can do that in one go. Yep, that worked in one go. Nice. Let's have a closer look here if we're now more on center. Yep, not perfect, I guess, but it looks much better now. At least visually, I can't see any problem. And what you can also see is that the whole thing, yeah, we didn't touch basically that edge here, and we used that to mill down the other side here. Yeah, it's not nice, but we're getting there. We have 3 more drills to get perfect. And here I can show you also the deflection we have here in the whole thing. Trying to drill in an offset hole. You see that? Now we're in. So hopefully we will get rid of that also in the next 3 steps. And the next step is, of course, 15 millimeters. And yeah, I use the caliper to align left and right, and that takes a while. Yeah, it looks good, and we will see now here with extreme magnification if we still got a little deflection here. Wish me luck. Okay, I want to go back to a total showing you the whole thing, but it went so well with the 15 millimeter drill. Yeah, I stalled out the 14.5 a few times, probably because we were trying to drill into a center-wise into an already off-centered hole. You probably saw at the beginning there was some deflection, but if we now look at the hole, yeah, there might be still some deflection there, but it's now very minimal. So let's go to 15.5. The drilling operation before the last. I swear to you, I'm spending much more time tapping the head to the left and the right and measuring and the left and the right with the caliper than actual drilling. Anyway, 15.5. The drilling operation before the last. And we overheated. I'll be back in 5 minutes. Things cooled down. Last few millimeters. That's it for 15.5 millimeters. 16 millimeters! And I forgot to film the first 20 millimeters down. Sorry. Okay, this is a little bit but I have one more joke up my sleeve. We will lubricate with a tiny little bit of denaturated alcohol in the hopes that, yeah, I put something into the hole in the hopes that this will reduce the friction. And it works like a charm. And now my battery died in between. Yeah, well, but it's really pretty boring. I'm going down a few millimeters and then I have to add more loop and then I have to go down, out again and let things cool, more loop, a few more millimeters down. I don't think I will film that. It's quite laborious, that last step, the last 60 millimeters. I didn't expect that because 15.5 went so well, but yeah, it is what it is. I'll come back to you when I finish the 60 millimeter. Okay, it's about an hour or 1.5 hours, 2 hours. I lost track of time later. I'm down to 60 millimeters, not quite 70 millimeters, but about 60 millimeters, and there is, yeah, no way. I mean, I was basically scraping off the bottom millimeter or half a millimeter at a time for the last 20 millimeters, and then yeah, relubricate, maybe take a break, let things cool down. Yeah, no way I can do the last 10 millimeters with that setup. So I will think about a solution for that. For now, I think we're done. Let's see if we at least is recovered from our slightly misaligned hole. So on that side we have, yeah, let's say 26.8. And on the opposite side we have, a little bit hard to do that around the camera, would you believe that? Well, let's say 27.05. Yeah. And here we have 27.33. And here we have 26.53. Interesting. 26.59. In green, we have the measurements I just showed you on camera, but I repeated that off camera without working around the camera, but the measurements were within a few hundreds. Then again, I took the delta, taking the average of the two measurements I took, and for the y-axis, we are now down from a delta of 0.45 millimeters to 0.26 millimeters. And accordingly, the offset is down from 0.225 millimeters to 0.3 millimeters. That's almost okay. It's not quite okay, but it will work. Now for the x-axis, we're down from an offset of a catastrophic, will not work, 1.48 millimeter with an offset half of that, 0.74 millimeters, to a delta of 0.755 millimeters. So we almost, halved our delta, respectively our offset, from 0.74 millimeters, which was 10,000 Röntgen, to 0.378 millimeters. That's not even close to good, okay? But that's the difference between Chernobyl and Fukushima. Will the part still work in the great scheme of things? Yeah, probably. We'll see. We first have to solve that other problem, that the hole is not completely through. I will have to think about that. That's it for today. Who would have thought that drilling 10 holes into a square POM block might be such a challenge. Okay, to be fair, the big 60mm hole was the challenge, and I did some mistakes in thinking that I can do that with the scribed lines here on the column to be exact, and I was totally off, and we recovered half of that error, and all in all, 60mm, it was doable. But in the depth of 70mm, we have to go down in the last 10mm. My mill really talked out. Okay, there was absolutely nothing going anywhere. We will solve that another day, I think. Till then, bye.